In the following slides, we discuss the main parameters affecting coastal erosion. Namely, they are climate, wave regime, coastal currents, lithology of coastal regions, global sea level rise. We will discuss each of these separately. The climatic regime defines the weather conditions of a particular area and consequently the physical phenomena of the coastal zone, such as waves, underwater currents, coastal currents, and storm surges. The wind regime is the most important climatic variable for coastal erosion processes. The stronger the wind, the larger wave height, and therefore erosive action. The influence of wind on the waves is owed to the drift of the surface layer of seawater through friction. Gradually, this movement of water molecules is extended to the deeper layers, resulting in the development of wind waves. The later ones, as they move towards the shore, impact on the coast with great velocity, causing intense erosion on existing cliffs with undercutting or by sweeping coastal sediments offshore. Storm conditions cause intense erosion on coastal environments. The resulting storm surges are much larger in height than the average wave height of an area. This happens because on the later one an additional height is added, which is owed to the disturbance of the sea mass because of the storm and the related barometric law. The wave regime is directly related to the wind conditions in the coastal area. The more intense the wind, the more erosive is the wave action as they break on the coast. Therefore, wave action is a defining parameter in coastal geomorphology. Waves, in fact, have a double part. They undercut coastal cliffs and they transport the weathering products that are accumulated at their base. Coastal currents transport loose sediments of the coastal zone, which derive either from fluvial processes inland and are deposited on the coast, or from the weathering of coastal cliffs. In this way, they are a significant factor in the sediment balance in the coastal zone and therefore in coastal geomorphology. The continuous arrival and breaking of waves on the shore causes the accumulation of water in the surf zone, resulting to the development of currents either parallel to the shoreline, longshore currents, or directed to the open sea, rip currents. The type of coastal currents in an area depends on the angle of wave incidence on the coast, the morphological characteristics of the shore, as well as the submarine geomorphology. Rip currents are actually responsible for transporting sediments from the shore to the open sea. They are strong currents of small amplitude and they initiate at the breaker zone. Their characteristics depends on the sea level rise at the breaker zone due to the accumulation of water mass in front of this zone. Their length may reach 60 up to 750 meters, while their velocity ranges between 20 centimeters per second and larger than 2 meters per second. The lithology of coast is a very important parameter with regard to coastal erosion. The main parameter controlling erosion is the rock hardness, namely its resistance to subaerial and marine erosion. The rock's resistance to erosion is largely defined by its lithology. You may see in the slide that different rock types are characterized by very different erosion rates. Granitic rock, for example, are more resistant and quaternary deposits or loose volcanic deposits have a high erosion rate. Tectonically vulnerable areas may provide sites of accelerated erosion because of intense faulting and thrusting. Exposure to wave activity is also significant not only because waves actively erode the cliffs, but because they also remove material from their base. The height of a coastal cliff is also significant. Lower cliffs are eroded quicker than higher ones, since less material needs to be removed for the cliff to retreat. Coastal constructions in particular may lead to the disturbance of coastal currents and the relocation of the protective beach in front of the cliff, leading to accelerating erosion. In coastal zones with large wide beaches and no rocky cliffs, the erosion of sediments is more extensive and depends on granulometry. In coarse-grained coasts, the erosion is less significant in comparison to fine-grained coasts as they have more resistance to wave energy. Wave penetration is promoted by the existence of voids between grains. On the other hand, in fine-grained coasts, erosion is very significant because grain compaction is greater and the penetration of waves within is very limited. Here we can see an example of a sandy beach in front of a coastal cliff which reduces its erosion rate by protecting its base. Another important factor is global sea level rise. Although sea level rise is a normal phenomenon during an interglacial period, it appears that this rise is amplified by the anthropogenic global warming. The continuous global warming results of the continuous sea level rise due to the thermal expansion of ocean water in combination with ice sheet melting. You may see in the table how these phenomena contribute to the global sea level rise. You may see in this figure the rise in global mean sea level from 1880 to 2013 relative to 1990 level based on two sources. The green line shows a reconstruction for 1818 until 2009 from coastal and island tide gauge data, while the dark blue line shows a time series for 1993 until 2013 based on altimeter data. In order to estimate the risk of sea level rise in a particular area, several factors should be taken into account. First of all, the rate and extent of rise. Then, the relationship between tectonics and airstasi in an area. Tectonically active regions eliminate or reinforce sea level rise depending on block movements. Last but not the least, the relationship between sea level rise and changes in sediment supply. The change may result from a climatic change, anthropogenic or natural, through which erosion rate will be affected as a consequence of precipitation variations and vegetation cover or human interventions such as construction of dams, sand extraction, fires, etc. The ongoing and expected rise of eustatic sea level is causing a great concern in coastal countries. Sea level rise can cause coastal erosion, flooding of wetlands, and salt contamination of coastal aquifers. Human activities on the coastal zone will be greatly disturbed, traditional means of transport will be affected, and farmlands will become unsuitable. In the map, you may see European coastal lowlands most vulnerable to sea level rise. In order to design the future uses of the coastal zone and to mitigate the problems caused by sea level changes, it should be possible to predict the response of coastal environment to the rising sea level. In reality, coastal environments respond to sea level rise by redistributing coastal sediments. Usually, sea level rise results to coastal erosion and shoreline retreat. However, it is also possible that the shoreline position may not change or move towards the sea. A crucial factor is sediment budget. A coastal area with positive sediment budget may expand instead of be eroded under sea level rise conditions. Likewise, coastal erosion due to sea level rise will be intensified in case of negative sediment budget.